Users can always arrange attributes any way they like in a cube browser, but usually it's helpful to add a user hierarchy for them. User hierarchies are never auto-detected. We need to add them manually. To create a hierarchy, we just drag attributes to the Hierarchies pane in the Dimension Designer and arrange them in levels like we see here, where calendar year, quarter, and month are arranged in a hierarchical order. When the user selects this hierarchy in a browser, such as Excel as an example, the user can drill from one level to the next. Here we see 2005 at the calendar year level, which is expanded to show the quarter level. Then quarter 3 has been expanded so we can see the month level of the hierarchy. Adding a hierarchy not only helps users navigate more efficiently from summary to detailed data, but it can also improve query performance when a hierarchy contains a natural one-to-many relationship between each level in the hierarchy from top to bottom, such as exists between year, quarter, and month. When these one-to-many relationships exist between levels, analysis services can store data more efficiently and can also build aggregations to pre-compute data in the cube. When a user asks for sales by year, for example, the server doesn't have to scan through each transaction and then group by year. The yearly totals will be available either directly or indirectly, which is much faster than summing up the data at the transaction level. We'll learn more about aggregations in a later module in this course. We might decide to allow users to access an attribute exclusively from within a user hierarchy. This is useful particularly when we have a very large set of members in an attribute, such as customers, and we want the users first to use a hierarchy to filter down to a smaller set, such as customers in a particular city. To do this, we set the attribute hierarchy visible property to false for each attribute that we want to hide this way. The attribute will be visible only within a user-defined hierarchy and not within the independent attribute hierarchy. Incidentally, we call this type of hierarchy a natural hierarchy when each level in the hierarchy has a one-to-many relationship with the level below. We can also create an unnatural hierarchy. The purpose of an unnatural hierarchy is to just provide a predefined grouping of attributes. So for example, in the product dimension, we might have users who frequently analyze product sales by color and by size. So we set up the hierarchy with the color and size attributes as we see here, and then users can use this hierarchy in the browser to drill from color to size. In a natural hierarchy, a member in a lower level can be associated with only one member in its parent level, but here we see sizes like large and medium associated with both the multi and white colors. In an unnatural hierarchy, we do not get any query performance benefit. It's simply a convenience for the users to have common groupings available, and it's completely optional.